Hi everyone, welcome to the 10th session of Python Basics. In this session, we will learn about the if statement. Basically, we'll learn about if-else and if-elif-else. So, how does this work? Suppose we have a number is equals to, we'll say 10, and if number is greater than 0, then we will say print positive number. If we execute this, what will happen? Because this number is 10, we will assign 10. This number 10 is greater than 0, so this will always be executed. This will be positive, and the line what will be printed will be both positive number as well as this line will always be printed. We'll execute and we'll get the output. So you can see positive number as well, this line will always be printed. Now what we'll do, we'll make it this number as 0. In this case, our if condition will not be satisfied and only this line will always be printed. And similar will be the case with negative. Now, I have already explained about how we'll take the input from the user. So we'll say number is equals to, now again we'll write one more if else. Okay. In this case, we'll say if number is greater than equals to 0, print, either we can print positive number or 0. If this is not the case, then we will say else print negative number. So if you see this, if we execute this, if we give 100 is greater than equals to 0, then it will be either positive or 0. We'll again execute this, minus 20, negative. So these are the simple cases of if else, but we will be gradually moving on to the complex case. Now what we will say, we will just copy this entire logic. We'll copy and we'll again paste here. Okay. And then what we'll do, we will say if the number is greater than 0, then print positive number elif 0. Now elif works on the condition that if any of the conditions satisfied, it will come out of the if else scenario. Now we'll execute this. Suppose we give 20 positive number, we'll again execute this, we'll give here 0. So that how it is working. And again if we give here, if I give minus 4, so it shows negative. Now to give you a more the detailed understanding of else if, what I will do, we will create the logic of a triangle, and then we will find out whether the triangle is a scalene triangle, it's a right angle triangle, whether it's a isosceles or equilateral, or whether it can be formed on. So suppose this is my triangle and these are the sides ABC. In our program we'll say side 1, side 2, side 3. Okay. So what we will do, we will get 3 input. Side 1 is equals to int of input. The basic rule of geometry says if the sum of two sides should always be greater than the third side, then only the triangle can be formed. So in our case, what we'll do, we'll first of all write if side 1 plus side 2, if it is greater than side 3, plus side 3 plus side 1, it is greater than. If this is the case, then we can say print else print triangle cannot be formed with the given dimensions. Okay, so in this case we will simply execute this. We'll give the side A as, suppose we'll give the side A as 3, side B as 4 and side C as 9. So if you can see the sum of the first two sides, 3 plus 4 should be greater than 9, right? And here it's 3 plus 4, 7. 7 is less than 9. And it should say that triangle cannot be formed with the given dimension. Okay, mistake I did is, here it should be AND condition, not the plus. Plus was that was by mistake. Okay. Here, if we say that like side 1 plus side 2 is greater than side 3 and side 2 plus side 3 is greater than side 1 and side 3 plus side 1 is greater than side 2, then only the triangle can be formed. So let us execute this once more and we'll give the same value 3, 4 and 9. So triangle cannot be formed with the given dimensions. Now we'll execute this once more, and now what we'll give 3, 4 and 6. Triangle can be formed. So till here it's very easy. Now what we'll do, we'll apply LF. Now LF side 1 equals to side 2, okay, and side 2 equals to side 3. Then it's a clear case of all the sides are equal. Print the triangle is equilateral. Again, we'll give else if side 1, in case of isosceles triangle, it can be side A is equal to B, or B is equal to C, or C is equal to any of the two sides should be equal. So what we'll do, else if and side 2 is not equals to side 3, okay, then we can say print isosceles triangle. Again, it can be right in this case. This is only the case of isosceles triangle where only my first side A and side B equal. It can happen that side B and side C can be equal, or side C and side A can be equal. So we have to repeat this 2 times. So what will we do? We'll do side 1 equals to side 2. Here we'll give side 2 is equals to side 1. Similarly, in this case we'll say side 3 is equals to side 1, side 1 not equals to side 2. Here easily, like we will printing whether it's a isosceles triangle. Yes, we'll execute this. We'll give 5 triangle can be formed. But if you see here, because we have the print condition, LF will not come. So what we'll do, we'll if and we'll give, okay, now if we execute this, okay, if we'll give 3 3 5, so it's an isosceles triangle. Again, if we say, we'll say 9 9, it's an isosceles. But what we'll do now, we'll give 5 6 6. So this is an isosceles triangle, two sides are equal. Now we need to show, like I have already shown, that it is an equilateral triangle. And now you see, after this, if this print is already executed, that's why every time when we execute, triangle can be formed is coming. And what is the case when we will have the scalene triangle? It is a case when the size, sum of the, like all the three sides are unequal. Then we can say LF side 1 is not equals to side 2, and side 2 is not equals to side 3. In this case, we'll give 3 4 5. So triangle can be formed, and this is a scalene triangle. We have seen that this triangle can be formed, but we can also know what is the right angle triangle. Right angle triangle is nothing where the sum of the square of the two sides is equals to the square of the third side. So in that case, we can say LF side 1 square plus side 2 square is equals to side square. Then we can print right angle triangle. Now this can be, again, can be true for the other two sides also. We can say side 2 square plus side 3 square is equal to side 1 square, and again side 3 square plus side 1 square is equal to side 2 square. Means this is like a square plus b square is equal to c square. This is like a b square plus c square is equal to a square, and this is like c square plus a square is equal to b square. Now in this case, what I have already said, that the moment the very first condition it's satisfied, it will come out. Even the condition which is true in the later part, like if this is true, okay, if there are two conditions are true, but the very first will be executed and it will come out. How two conditions can be true, I will show it just now. Now you see here, this side 3 4 and 5, 3 4 and 5 is an example of scalene triangle. None of the sides are like equal, but if you do the squares of 3 square plus 4 square, 9 plus 16, and sum it 25, 5 squares 25. So even though this line will be, line of code will satisfy, but it will not be executed, because the moment it hits this logic for scalene triangle, it will come out. So we'll see this. Here should be equal to okay, and then we will record. So okay, so side A will give 3 4 and 5 scalene. Will give the logic of LF after this. Now, in this case, what will happen? The right angle triangle will be executed first. We'll show this. 3, 4, 5. You can see this right angle triangle is executed first. So that's how the logic of if, elif, and if-elif-else will work. So thanks a lot for watching this session. If you feel this video is helpful, please press the like button and subscribe to this channel, and I'll see you in the next video where I'll be coming up with nested for loop and also the while loop. Thank you.